Good day everyone, this is Sir Erwin, your math teacher. Welcome to another video lesson. In this video, we will be discussing the systems of nonlinear equations. At the end of this video discussion, students should be able to recognize the equation and important characteristics of the different types of conic sections, illustrate systems of nonlinear equations, and determine the solutions of systems of equations in two variables using substitution. Let's start with the characteristic of the general equation of conic. In the given general equation of conic, ax squared plus 2bxy plus cy squared plus 2dx plus 2ey plus f is equal to 0, it will be a circle if the value of b is equal to 0 and the value of a is equal to the value of c. Parabola, if the value of b squared minus ac is equal to 0, an ellipse if b squared minus ac is less than 0, and a parabola if the value of b squared minus ac is greater than 0. For our example, we are asked to identify the type of conic from the given equation. So the equation is x squared plus 4xy plus 4y squared plus 2x is equal to 10. First thing to do is to equate the equation to 0. It will become x squared plus 4xy plus 4y squared plus 2x minus 10 is equal to 0. And then we have to check the missing term, all the missing terms from this equation based on our general equation of conic. So the only missing term is our y term. Why? Because we have x squared, we have xy, we have y squared, we have x term, and we have the constant 10 in terms of f. And the only missing term is the term of y. So we have to fill this out in such a way that it will have a zero numerical coefficient. So it will become x squared plus 4xy plus 4y squared plus 2x plus 0y minus 10 is equal to 0. We can now determine for the value of a, b, and c. So for a, value of a, we have ax squared equal to our x squared from our equation. So we have to multiply this both sides by 1 over x squared in order to determine the value of b. So that is cancel for the left side and cancel for the right side also. So we have a is equal to 1 in our right side. So this is the process of commutative property of equality by multiplication. For the value of b, we have 2bxy. So we have 2bxy, 2bxy equal to our xy term here, which is 4xy. So we have 4xy. Solve for the value of b. We can now cancel out this xy and multiply both sides by 1/2. 1/2 in order to eliminate 2 beside b, or the numerical coefficient of b, which is 2. So we have to cancel this out. So for our left side, the only remaining variable will be b, and for our right side, we have 4 over 2, that is equal to 2. So our b is equal to 2. Now for letter c, or for the value of c, we have to use cy squared. So our cy squared here is this cy squared equal to our y squared term here, which is 4y squared. 4y squared. So we have to eliminate y squared. So the value of c is equal to 4. Since we already have the value of a, b, and c, we can now determine what type of conic section is the given equation. So let's check if it is a circle. Is b equal to 0? No. b is equal to 2. Therefore, this is not a circle. Next, what is the value of b squared minus ac? So we have to solve for b squared minus ac. Okay, so our b here is 2 squared minus a, which is 1, times c, which is 4. And then we have 4 minus 4. 4 minus 4 is 0. And if b squared minus ac is equal to 0, then it is a parabola. Therefore, this given equation is a parabola. Parabola. Another example, so we have to identify what type of conic section is given from this equation. 9x squared plus 16y squared minus 36x minus 32y minus 92 is equal to 0. So first thing to do is to equate this to 0. Since this is already equated to 0, we have to check what is the missing term based on our general equation of the conic. So the only missing term here is the term of xy. We do not have any term of xy here from our given. Therefore, we have to substitute a numerical coefficient equal to 0 in that term. So we have 9x squared plus 0xy plus 16y squared minus 36x minus 32y minus 92 is equal to 0. We can now determine for the value of a, b, and c. So for our ax squared, that is equal to 9x squared. So we have to eliminate x squared, cancel this out. A is equal to 9. For our b, we have 2b squared, 2bxy rather, that is equal to 0xy. So we have to eliminate or cancel out xy and multiply both sides by 1/2 in order to eliminate the numerical coefficient 2 of b. So cancel this out. So this is equal to b equal to any number multiplied by 0, that is 0 times 1/2. This is still 0. And for the value of c, we have cy squared equal to 16y squared. Eliminate y squared or cancel it out. C is equal to 16. Now, since we already have the value of a, b, and c, which is 9, 0, and 16 respectively, we can now check what type of conic section is this. Is b equal to 0 for circle? Yes. But is a equal to c? No, because a is 9 and c is 16. Therefore, we cannot say that this is a circle because according to the concept of circle should be b equal to 0 and the value of a and c must be equal. Now let's compute for the value of b squared minus ac. Our b is 0 squared minus our a is 9 times 16. And then 0 squared 0 minus 9 times 16 is 144. 0 minus 144 is negative 144. Now let's compare this to 0. If this is equal to 0, then it is a parabola. If this value is less than 0, then it is an ellipse. If this value is greater than 0, then it is a hyperbola. Now comparing this to 0, negative 144 is less than 0. Therefore, this is an ellipse. The type of conic of the given equation here is an ellipse. Why? For our next example, we are asked to identify what type of conic section is the given equation. So the given equation is x squared plus y squared minus 4x plus 3y minus 20 is equal to 0. It is already equated to 0, so let's check the missing term. The only missing term here is the term of xy. We do not have xy term here. So we have to use 0 as its numerical coefficient. It will become x squared plus 0xy plus y squared minus 4x plus 3y minus 20 is equal to 0. After that, we can now determine for the value of a, b, and c. For our ax squared, we have to equate it to x squared. Here, our x squared. So cancel it out. It will become a equal to 1. Or multiplying both sides by 1 over x squared will give a equal to 1. For the value of b, we have 2bxy is to be equated by 0xy. So we have to cancel out xy and we have to multiply both sides by 1/2 in order to eliminate our numerical coefficient 2 of b. So cancel this out. For our left side, the remaining variable is b, and any number multiplied by 0 for our right side is still 0. And for the value of c, we have cy squared is equal to our y squared here. We have to cancel it out, so it will become c equal to 1. Using Commutative property of equality by multiplication, we have to multiply both sides by 1 over y square. It will still be equal to c is equal to 1. Since we already have the value of a, b, and c, let's check out. Let's check which of this conic section is the given equation. First thing to do is to check b equal to 0. Yes, so b is equal to 0. And then, is a equal to c? Yes, a is equal to c because a is 1 and c is equal to 1. Therefore, this given equation is a circle. For our next example, we have 2x squared minus 8xy plus 4x equal to 12. Let's check what type of conic section is this equation. So let's equate this first to 0. So 2x squared minus 8xy plus 4x minus 12 is equal to 0. And check all the missing terms. We do not have term for y squared, and we do not also have term for y. So we will be using 0 as the numerical coefficient of all the missing terms, y squared and y. It will become 2x squared minus 8xy plus 0y squared, which is the missing term, plus 4x plus another missing term, which is 0y minus 12 equal to 0. And then we can now check for the value of a, b, and c. For the value of a, we have to equate ax squared equal to our 2x squared. So we have to eliminate or cancel out our x squared. The value of a is equal to 2. Next, for the value of b, we have 2bxy equal to our xy term, which is negative 8xy. We have to cancel out xy, eliminate it, and then we have to multiply both sides by 1/2 using commutative property of equality by multiplication. So this is cancelled out. The left side will become b, and the right side will become negative 8 over 2, which is equal to negative 4. So b is equal to negative 4. And for our c, we have cy squared is to be equated by 0y squared here. So we have to eliminate y squared and c is equal to 0. Let's check first if this is a circle. So is b equal to 0? No, automatically the given equation is not a circle. So we have to use the formula b squared minus ac. So our b is negative 4 squared minus our a is 2 and our c is 0. So negative 4 squared is 16 minus 0. 16 minus 0 is 16. So what type of conic section is this? If b squared minus ac is greater than 0, then this is a hyperbola. Let's continue our discussion with the definition of nonlinear equations. A nonlinear equation is an equation in two variables with the highest exponent of 2 and above. Example is quadratic equation, cubic equation, and more. Thus, all equations of conic are considered nonlinear equations. Therefore, our previous equations of our previous examples are all nonlinear equations like the circle, parabola, ellipse, and hyperbola. Now let's take a look at the solution of systems of nonlinear equation. The solution of systems of nonlinear equation is or are the coordinates common to both. If the graph of the two conics intersects in some points, then their points of intersection is said to be the solution of the system. Example, we have an equation here, an equation x plus y squared equal to 4, and the second equation is x squared plus y squared is equal to 16. So let's represent x plus y squared is equal to 4 in our graph here. The graph is a parabola, which is a green parabola, And the second equation, x squared plus y squared is equal to 16, is a blue graph here, the graph of the circle. Now, what is the solution of this system? The solution of this system are the points of intersection, all points where the graph intersects. Another example, so we have x squared minus y squared is equal to 5 is the equation of the green graph, which is a hyperbola. And the second equation, x squared plus y squared is equal to 13, is the graph of the circle here, the blue circle. Now, the solution of this system of nonlinear equation are the points of intersection. So if you are going to observe, we have 4 points of intersection here. This is the first point, which is negative 3 and 2. The second intersection is 3 and 2. And the third intersection here is 3 and negative 2. And the fourth intersection is negative 3 and negative 2. All these points are considered to be the solution of the systems of nonlinear equation. Why? Because all these points are common to both equation or common to both nonlinear equations. So let's have an example. Determine what type of conic are the given equations. Also find the common points of the two equations or the solutions of the nonlinear equations. So let's first take the type of conic for the green equation. So our A is automatically equal to 4. B is equal to 0. Why? Because xy term is not existing and our C is equal to 1. So let's take a look at the concept if this is a circle based on the value of A, B, and C. B is equal to 0, but 4 and 1, which is A and C, are not equal. Therefore, this is not a circle. So we have to use B squared minus AC, and we have to take if this is equal to 0, greater than 0, or less than 0. So our B is 0 squared, and minus our A is 4 times 1, so that this is equal to negative 4. Now, if the value of B squared minus AC is negative 4 is less than 0. Therefore, this is an ellipse. Next, for our second equation, x squared plus y squared is equal to 10. So our A is automatically equal to 1. Our B is 0 because xy term is not existing. And for the value of C, we have 1 because the numerical coefficient of y squared is 1. So let's check if this is a circle. B is equal to 0. Yes. Now let's check if A is equal to C, and taking a look at the values, we have A is equal to 1 and C is equal to 1. Therefore, A is equal to C. Therefore, this is a circle. Now let's continue by determining the solutions of the nonlinear equations by substitution. First thing to do is to solve for one of the variables in one of the two equations. I think based on these two equations, the best equation to check or to solve for a variable is the second equation or the violet equation. So let's use this equation, x squared plus y squared is equal to 10 to solve for x or y. But in this case, I will be solving for x. Solving for x will be x squared equal to 10 minus y squared. And then we have to get the square root of this equation both sides in order to determine the value of x. So we have x is equal to square root of 10 minus y squared. Now, after taking the value of one of the variables, we have to substitute this value to the equation, which is the equation we do not use. So that is 4x squared plus y squared is equal to 13. So our equation 4x squared plus y squared is equal to 13 must have an x value of square root of 10 minus y squared, meaning we have to substitute the value of x to our unused equation. Therefore, it will become 4 times our value of x is square root of 10 minus y squared. And then we close this and raise to the power of 2 plus y squared is equal to 13. Now let's solve for the value of y. Now in order to solve for the value of y, we have to eliminate this, cancel this because it will become a power of 1. So we have 4 times 10 minus y squared plus y squared is equal to 13. After that, we have to distribute the common factor 4. We have 40 minus 4y squared plus y squared is equal to 13. And then we combine all the similar terms. So we have 40 minus 4y squared plus y squared is negative 3y squared is equal to 13. And we use commutative property of equality by addition. We have to add both sides by negative 40 so that 40 here in our left side will become negative in our right side. So it will become negative 3 y squared is equal to 13 minus 40. So we have negative 3y squared is equal to 27. 27. And then we use commutative property of equality by multiplication. We have to multiply both sides by 1 over negative 3. 1 over negative 3. So the negative will be eliminated, 3 will be eliminated. The remaining variable here is y squared equal to 27 over, this is negative 27. Negative 27 over negative 3. And then y squared is equal to negative 27 over negative 3 is positive 9. We are solving for the value of y. Okay, so in this case, we have to eliminate the power of 2 in our y here. So we have to use square root both sides. So we have y in our left side, and the value of the square root of 9 is positive and negative 3. So we have two values of y. Now since we have a value of y which is positive and negative 3, we can now solve for the value of x. How? Using one of these two equations, we can solve for the value of x. Now it's up to you which of these two equations you will be using. But in my case now, I will be using the second equation or the violet equation y because I have already solved for the value of x. I can easily substitute the value of y in order to solve for the value of x. So I will be having x equal to square root of 10 minus y squared. Now I will be using first the value of y equal to positive 3. Therefore, I will be having x equal to the square root of 10 minus 3 squared. So we have x is equal to square root of 10 minus 3 squared is 9. And then we have x is equal to square root of 1, and square root of 1 is equal to positive and negative 1. Therefore, if I have a value of y equal to 3, then I have values of x which is equal to positive 1 and x equal to negative 1 because I have two values of x here when I substituted the value of y which is equal to positive 3. Now, the second one is to substitute for the second value of y which is negative 3. So let y equal to negative 3. So I will be having an equation equal to square root of 10 minus negative 3 squared. Therefore, we have x is equal to square root of 10 minus 9. That's negative 3 squared is equal to 9. And x is equal to square root of 10 minus 9 is 1. Therefore, I also have two values of x when I substituted the value of negative 3, which are positive and negative 1. Therefore, if y is equal to negative 3, then I have already two values of x also. We have x is equal to 1 and x is equal to negative 1. What does this mean? Meaning we have four intersections or four solutions of this system. The first solution is if x is 1 here, we have positive. Point 1 is x is 1 and y is positive 3. Point 2 is that x is equal to negative 1 with y as positive 3. And then we have point 3 that is x is equal to 1, positive 1 with a negative value of y. And point 4 is a negative value of x, negative 1 of x, and negative 3 of y. So we have four intersections of this system when we plot the graph in the Cartesian plane. So these points are what we call the solutions of the systems of nonlinear equations. Looking at the graph of our first example, so for our green equation, we have 4x squared plus y squared is equal to 13. That is the green elliptical graph here, elliptical graph. And our pink graph, or violet graph, which is x squared plus y squared is equal to 10, is a circle here with a radius of more than 3 units. So if you are going to observe, we have four intersections. This is negative 1, 3. And this second intersection is 1, 3. And the third intersection here is 1 and negative 3. And the fourth intersection or fourth solution is negative 1 and negative 3. So these coordinates are what we call the solutions of nonlinear equations, or points common to both given nonlinear equations. For our next example, we are going to determine what type of conic sections are given and also find out the common points of the two equations, or what we call the solutions of nonlinear equations, systems of nonlinear equation. So let's start with 3x squared plus y squared is equal to 31. The value of a is equal to 3. The value of b is 0 because xy term is not existing, and c is equal to 1. Now let's take a look at this. B is equal to 0. Let's check if A is equal to C. Now 3 is not equal to 1. Therefore, we have to check what type of conic section is this, whether parabola, ellipse, or hyperbola. So we have B squared minus AC, and our B is 0. So we have 0 squared minus A, which is 3, and this is C, which is equal to 1. And 0 squared is 0 minus 3. And then the value of our B squared minus AC is negative 3. What type of conic section is this if B squared minus AC is less than 0? So this is an ellipse. Next, for our second equation, we have x squared minus 4y squared is equal to negative 7. So our A there is 1, our B is 0, and our C is negative 4. XY term is not existing, therefore B is equal to 0. So is B equal to 0? Yes. Is this a circle? Let's check if A is equal to C. 1 is not equal to negative 4, therefore this is not a circle. Therefore, we have to use B squared minus AC. Our B is 0, so we have 0 squared, and A is 1 times C, which is negative 4. So this is 0 minus, or I mean positive 4. That's positive 4. So 0 plus 4 is 4, and if the value of B squared minus AC is greater than 0, therefore this is a hyperbola. Now let's determine the solutions of these systems of nonlinear equation. First, we have to determine a certain value of x or y from one of these two equations. So I think I will be using the second equation, which is x squared minus 4y squared is equal to negative 7. It is easier to manipulate than the first equation. So I will be solving for the value of x. So we have x squared minus, equal to negative 7 plus 4y squared. And then we have to eliminate this power. So I will be using square root both sides. So cancel out this, and this is x equal to square root of negative 7 plus 4y squared. After that, I have to substitute this value from the unused equation. Our unused equation is the first equation, which is 3x squared plus y squared equal to 31. I will be substituting the value of x, which is this square root of negative 7 plus 4y squared, in my x in this orange equation. So I will be having 3 times the value of x that I have is negative square root of negative 7 plus 4y squared. So raised to a power of 2 plus y squared equal to 31. And then I have to solve for the value of y at this point of my solution. So I have to cancel this out, the power and the root. I will be having there a power of 1. So the remaining equation will be 3 times negative 7 plus 4y squared plus y squared is equal to 31. I have to distribute the common factor 3. So that's 3 times negative 7 is 21, negative 21, plus 12y squared plus y squared is equal to 31. And then combine all the similar terms as well as with the constant on the other side. So 12 plus 12y squared plus y squared is 13y squared. That is equal to 31 plus 21 on my right side. So we have 13y squared is equal to 52. That's 31 plus 21 is 52. And then I have to use commutative property of equality by multiplication. I have to multiply this both sides by 1 over 13. So cancel this out. I will be having my left side as y squared equal to, that's 52 times 1 is 52 divided by 13 here is 4. And then we still have a power of 2. We have to remove it using square root. So we have y on the left side and positive and negative 2 on the right side. So I have two values of y, positive 2 and negative 2. Now I can substitute this value of y from one of the two equations. Okay, but I think it is better for me to use the second equation here. The second equation, the blue equation, because I have already solved for the value of x of this equation, which is already equal to this square root of negative 7 plus 4y squared. I can easily substitute this value of y inside this root so that I could have a certain value of x. So I will be using x equal to square root of negative 7 plus 4y squared. So I have two values of x. I will be using first the value of, two values of y. I will be using first the value of y that is equal to positive 2. So if y is equal to positive 2, then my x should be square root of negative 7 plus 4 times my y is 2 square. Therefore, I have x is equal to square root of negative 7 plus 4 times 4. That is square root of negative 7 plus 16. That is x is equal to square root of 9. And the square root of 9 is positive and negative 3. Taking the second value of y, which is negative 2. So let y equal to negative 2. Our value of x will be equal to square root of negative 7 plus 4 times negative 2 square. And then we have x equal to square root of negative 7 plus 4 times positive 4. That's second power of negative 2 is positive 4. And therefore we have square root of negative 7 plus 16. And negative 7 plus 16 is positive 9. Square root of 9 is positive and negative 3. Therefore, we have two values of x when y is equal to negative 2. Okay, so let's segregate now the different intersections or solutions of the systems of nonlinear equation. For the value of x, which is positive 3, we have positive 2 and negative 3 and positive 2. So we have point 1 will be positive 3 and 2. And then point 2 will be negative 3 and positive 2. For the third point of intersection, we have point 3 is equal to, or point 3 is positive 3 and negative 2. And the fourth intersection of the system of the graph is negative 3 and negative 2. So we have 4 intersections of the system, or 4 solutions of the systems of nonlinear equations. Taking a look at the graph of our example, which is an orange equation here, which is 3x squared plus y squared is equal to 31, that is represented by orange elliptical graph here, and our blue equation, which is x squared minus 4y squared is equal to negative 7, is represented by the blue hyperbola. We can see here that we have 4 intersections. This is the first intersection, which is negative 3 and 2, followed by 3 and positive 2, and then we have negative 3 and negative 2, and the last one is positive 3 and negative 2. These 4 intersections are what we called to be, or known as the solution of the systems of the nonlinear equations. Sir, these items determine what type of conic are the given equations. Also find the common points of the two equations. First, 3x squared plus 4y squared minus 16 is equal to 0, and 2x squared minus 3y squared minus 5 is equal to 0. For item 2, we have 16x squared minus 4y squared minus 72 is equal to 0, paired by x squared minus y squared minus 3 is equal to 0. So, see you again for our next video discussion. Goodbye!